Good morning. Myself P. Jayaditya. I am from ECB section, bearing roll number 4C8. Now I am here to explain about the bipolar junction transistor. So this is also known as BJT. Now we will learn about in section learn about when BJTs and organics types, common base configurations, common base, common collector, and a small model, etc. Let's look into that. Understanding bipolar junction. This is the structure of BJT. This is the structure of the BJT. For a bipolar junction transistor, name itself, we can know that bipolar, which means it has two poles. Junction transistor. We can learn about the junction transistor in the further side. First step, this is the emitter transistor. This is the base terminal and this is the collector terminal. It is a three-terminal device. See this. From this figure, we can understand that base, emitter and collector are connected. The comprehensive explanation of BJT collectors, configurations, applications in modern analysis. And what is a junction transistor? First, there are two types of transistors, PNP transistor and NPN transistors. Now let us take NPN transistors. Let us see what is the junction transistor. The BJT, which means a bipolar junction transistor, invented by William Stockley in 1948. This BJT was invented by William Stockley. It is a three-layer semiconductor device which consists of two PN junction diodes. It can be arranged in three terminals E or PNP4. It consists of three terminals, that is such as emitter, base and collector, either NPN or PNP types. The transistor uses both electrons and holes as a charge carriers. For every transistor there will be a charge carriers. We know that there are holes and electrons. Uh, for if you take in PNP transistor, the hub carriers are major are holes. If you take NPN, majority carriers are electrons. Right. Enable reset current through the signal of controls. Now let us observe this. Two main types, N, NPN and PNP. Electrons are major carrier in NPN. In PNP, holes are major carrier. Three terminals, BJT. It has three terminals, emitter, base, collector. From the emitter, source of the charge carriers. The charge carriers are current from each and everything to the emitter. Base. It is a control terminal, which means it control all the voltages and current by and destroying the transistor. Collector, output terminal. Here we see that and put the output, gives the output. When you give the input, it gives the output in the here. The key features: small base current control large collector current from amplifier, which means a small change is a large change in the collector current. Next, transistor current component. As I said that there are three terminals: emitter, base, collector. For each and every terminal, there are current components. The emitter current IE represents total current output current, while the base current IB is small control signal, and the IC is a collector current, amplified current. Now this current follows as precise mathematical relationships. Now I want to buy the current meter. What is this beta? This beta is the current gain. Next, first emitter current. Emitter current enters into the through the emitter and base current. It controls the current. Next, collector current. It is the output current. Now the relationship between IE and IC is IE emitter is equal to I collector plus I base. Now this is the current gain. Now IC, which means collector current, is equal to beta IB when beta is a current gain. Similarly, the value should be 500. Next, transistor equation in common base configuration. As I said that there are three configurations: common base, common emitter and common collector. Now let us learn about common base configuration. In the common base configuration, the input signal is output the emitter and base. The input signal is applied between emitter and base. Emitter and base. This is emitter and this is emitter. Between the emitter and base, by the output is taken from the collector and base. Output is taken from collector and base. Next, this arrangement reviews the function from the fundamental relationship between the collector current and the short circuit. Uh, it is a short light diode equation. It is a diode equation where we can find the relation between collector current and applied voltages. The current gain alpha before the current gain beta. Now the current gain is alpha. Next, consistently goes to across the operation condition. Now let us see the collector current equation. The equation of the collector current is IC equal to, where IS means saturation current, which is the maximum reverse saturation or positive saturation, maximum current. A true e power exponential of VBE by VT minus 1. What is VBE? Base emitter current. The VTB is the threshold voltage, which means uh, voltage equivalent temperature, which is 25 millivolts, and room temperature. It is volt equivalent temperature. This is the collector current equation. Now the value of our phase goes to, what is the definition of alpha? It is a current gain. It is the ratio of collector current to the emitter current. Typically, it is always nearly 0.98 to 0.99. Configuration less than 1. And high voltage, no current gain, low input and high input impedance. As these regions note the collectors, we introduced the common emitter configuration also. Before that, we can learn about the transistor when acting as an amplifier. What is the main role function of the transistor? It acts as amplifier and a switch. When transistor acts as an amplifier, a small current in the phase related changes the large current in the collector. Let us observe it. Transistor amplification work in active region. When active region means the base emitter is the forward bias and collector base is the reverse bias, where base emitter junction is forward bias and collector junction is reverse bias. This configuration allows a small base current to modulate series. This configuration allows small base current to modulate a large collector current. As I said that a small change in base current also produces large current, a change in a collector, effectively amplifying weak signals. The weak signals are amplified because the amplifier will be amplified. Transistor is used as amplification. Common emitter configuration is the most popular, providing both voltage and current gain with the excellent over performance. Common base configuration did not perform very well. So common emitter configuration performs very well, excellent, more, and performance very good. Next, forward biasing base emitter, reverse biased base collector, and amplification enables charge carriers injection into the base, maintain large deflection region of collector current collection. Next, characteristic characteristics of common base configuration. See this: input characteristics and output characteristics. Input characteristics are plotted between the emitter and base, emitter current versus base voltage. Next, output characteristics are collector current versus collector base voltage. See this: input characteristic consist of two impedance and output characteristic consist of I impedance. Next, characteristics of a common emitter configuration. Common emitter configuration, like so that common emitter configuration also has uh, same characteristics. Same likewise, input is taken as base and base emitter, hence base collector into base. When output is taken from the collector as collector emitter, impedance, it it moderates the common base and input high output impedance, low and equal to the low output, and high outputs are given. Gain, it is a current gain is beta. Here current gain is beta. Now common emitter configuration is low to and widely transistors. It provides both current gains and voltage gains, making suitable for general purpose configuration. It moderate input impedance, high input impedance. Common emitter configuration for excellent overall. See there, as I said that it provides excellent overall performance for audio or signal amplification applications. Characteristics of common collector. As we already said that characteristics of common base and common emitter. Now let us see the common collector configuration. We will also know as CC configuration, also known as emitter follower. A common collector configuration exhibits, see the diagram to the common collector configuration. Here the collector is displaced in the common, which is connected to the ground, and we can observe the base, and it is the base and it is the emitter. This is the collector. Now let us look into this. Also known as emitter follower collector configuration exhibit unique impedance characteristics. Impedance characteristics valuable for impedance matching and buffer applications. This is also used for buffer applications. While current gain is present through the beta parameter. The voltage gain parameters using the voltage gain approximately is equals to 1. Next, the configuration high output impedance as the common emitter configuration and low output impedance, making it ideal for driving voltage low and also the signals. Circuit characteristics input base current and output emitter current and the voltage gain, as I said that voltage gain is nearly approximately equals to 1 and the current gain is the beta. Impedance properties, it has high input impedance and low output impedance, excellent impedance amplification factors, buffer amplifier application, it is also used as buffer amplifiers. Next, the Ebers-Moore model of a transistor. The Ebers-Moore model. It is a mathematical model framing from understanding in which transistor in all regions, all operating regions. There is two equations are, that is collector amplification and emitter amplification. Let's look at this. The Ebers-Moore model from its mathematical framework, understanding BJT behavior across all operation regions, from cutoff region through saturation region, which means cutoff region and active region and saturation region. This model expresses both collector and emitter current as a junction current voltage and captures the forward and reverse operation with high accuracy. It is a mathematical model which explain about the all operator regions, and in these current equations are there. There are IC and IA. First, IC means collector current. IS into e power VBE by VT. What is the VT? It is the threshold voltage or voltage value of your temperature. Next, uh, IC is equal to IS into VB by VT minus e power VBC by VT by beta R. What is beta? It is the current gain. What is R means? It is reversed current gain. I is equal to IS into e power VBE by VT minus e power VBC by VT beta F. Here beta F means forward current gain. What does it capture? It capture forward and reverse operations mode, include a saturation and cutoff behavior, provides accurate circuits in simulation capabilities, foundation for spice and model designs of tools. Diaper force model specification, these are the specification, which means uses or applications of this. Reverse Ebersmall model summary. Master BJT for modern electronics. All the concepts we learn from them are the present in the summary. Bipolar junction transistor remains fundamental devices in electronics, controlling large through small. It is mostly used in the electronic devices also. Circuit the currents through the small base current we have in the PN junction diode. As we discussed, PN junction diode. Each configuration powered is common emitter and common collector of distinct advantage. For common base, there is different advantages. For common emitter, there is different advantages. For common collector also there are different advantages. Common base provides voltage gain and at high frequency response. What does common base and advantage? What is advantage of common base? It provides gain, high frequency. Common emitter delivers balanced current voltage and voltage gain. The current is balanced, which means the voltage current and voltage gain for amplification. Voltage is amplified. Next, common collector. It expels the input impedance matching. Next, transistor equation, Ebers-Mould model. Together the complete instead of device. What does this Ebers model? It is a mathematical model. It operates when we applied in continue the current equations of emitter and collector current. What does it provide? One side in a behavior, which model we can understand this device behavior, enabling engineers to design efficient amplifiers, switches and signals process in applications from what do you do in different frequencies. In all the slides we learn about different operations and mathematical foundations which consists in Ebers model and practical designs enable in amplifiers and switch across all applications, which is the summary, which means all about the same. Thank you for giving opportunity. Thank you.